Okay, today is going to be a quick review of the two-step equations and some of the special cases that show up in each. You learned how to solve one-step equations in 6th grade. You did two-step equations in 7th grade. You also learned your integer rules in 7th grade. Remember, when you are solving equations, your goal is to isolate the variable. You're trying to get the variable all by itself. You do this by using inverse operations. So the inverse of addition is subtraction, the inverse of multiplication is division, and you also use the golden rule. Whatever you do to one side of the equation, you have to do to the other. So we're going to start with a very basic one-step equation, y plus 7 equals 10. Here's my variable. I'm trying to isolate it. I'm adding 7 to y, so the inverse of addition is subtraction. I'm going to subtract 7 from the left side of the equation and from the right side of the equation. Whatever you do to one side, you have to do to the other. Y, then plus 7 minus 7 becomes 0. We do not write that 0. I bring down my equal sign. Never lose your equal sign. And 10 minus 7 is 3. The next one, q minus 11 equals negative 5. Q is my variable. I'm subtracting 11 from q. So the inverse operation, I'm going to add 11 to q, or add 11 to that side of the equation. And then since I added it on the left, I have to add it on the right. Q equals negative 5 plus 11 is 6. Remember, you can always check an equation. If I plug 6 back in for q, 6 minus 11 does in fact equal negative 5. Then we have one that tends to confuse people. We have this t over negative 3. That over, that fraction bar, that's a division bar. So this is t divided by negative 3. The inverse operation to division is multiplication. So I'm going to multiply the left by negative 3. I'm going to multiply the right by negative 3. This is really negative 3 over 1. Negative 3 in the numerator, negative 3 in the denominator cancel. They become 1. I'm left with t on the left. And 9 times negative 3 is negative 27. The last one, 24 equals negative 8n. Remember, when two things in algebra are written side by side, that means multiplication. So the inverse operation is division. Do not, in an algebra equation, use the division symbol. That's arithmetic. We are now in algebra. So we're going to divide both sides by negative 8. And the way we show that is with the division bar. So the negative 8 divided by negative 8, that's going to cancel. I'm left with 1n, or just n. And 24 divided by negative 8 is negative 3. Okay, a special case of a one-step equation is when we have a fractional coefficient. That means the number in front of the variable is a fraction. So here I have 5/6w equals 10. Remember that written side by side, that means multiplication. So the inverse of multiplication is division. I'm going to divide both sides by 5/6. Okay, now this looks a little weird. We know right here that the 5/6 over 5/6, that's going to cancel. No big deal. We're left with w. Now, on the right, we have 10 divided by 5/6. How do we divide by a fraction? We multiply by the reciprocal, right? So we put the 10 over 1, 5 goes into 10 two times, and 2 times 6, we get 12. So that one, they were nice to us, and we ended up with a whole number answer. The next one's very similar. It's negative 4/5 times v. So we're going to divide both sides by negative 4/5. Negative 4/5 divided by negative 4/5, that cancels. I'm left with v. Now, if you need to go to the side, this is negative 8 divided by negative 4/5. So to divide by a fraction, you multiply by the reciprocal. The negative times the negative is going to be a positive. We put that over 1. 4 goes into 8 two times. Negative 2 times negative 5 is a positive 10. All right, another situation that sometimes causes problems. Here you see 5 minus x equals 7. The x is in the middle. That confuses some people. And the subtraction sign goes with the x. The x and the minus sign sort of belong together. I've got to get rid of this 5. It's a positive 5, right? There's nothing out here. So this is a positive 5. So my inverse operation, I'm going to subtract 5. I'm going to subtract 5 from both sides. 5 minus 5 is 0. And I bring down the minus x. Okay? Don't lose that minus sign. So I have minus x equals 7 minus 5 is 2. Now, what on earth do I do with the minus x? I don't want minus x. I want x. Well, this is negative 1, right? There's a negative 1 there. So I'm going to divide both sides by negative 1. Negative 1 divided by negative 1 gives me the positive x that I want. And 2 divided by negative 1, almost forgot it there, didn't I? 2 divided by negative 1 is negative 2. We're going to do it again. Negative 3 minus y equals negative 10. First thing I've got to do is I've got to get rid of this negative 3. It's a negative 3, so I'm going to add 3 to both sides. Negative 3 plus 3 becomes 0, and I'm left with a minus y. Don't lose that minus sign. Negative 10 plus 3 is negative 7. Since it's negative y, this is really a negative 1y. We just don't write it. So we're going to divide both sides by negative 1. Those negative 1s will become positive 1. So y equals negative 7 divided by negative 1 is 7. All right, two-step equations. You spent a lot of time last year with two-step equations. 5x plus 9 equals 24. I'm trying to isolate the x. I have to get rid of the plus 9 first. So I'm going to subtract 9 from both sides, and I get 5x equals, what's 24 minus 9? 15. Then it's 5 times x, so I'm going to divide both sides by 5, and x is 3. Next one's very similar. 4y minus 4 equals 16. I'm trying to isolate the y. You want to take care of the addition or subtraction piece first. You sort of do the opposite of the order of operations. So you're going to add 4 to both sides. I get 4y equals 20. Divide both sides by 4, and y is 5. That's the way we're used to seeing our two-step equations most of the time. Sometimes they'll put this division here, but it's the same thing. I'm trying to isolate the z, so I'm going to save that to the end. It's minus 7, so I'm going to add 7 to both sides. Negative 1 plus 7 is 6, and that is z divided by 3. It's divided by 3, so I'm going to multiply both sides by 3. 3 times 6 is 18. These 3, since one's in the numerator and one's in the denominator, they cancel, and I'm left with z. Okay? Now, this last one's very similar, except it's got that fraction in front of the variable. Still got to take care of that minus 1 first. I'm going to add 1 to both sides, and I get 3/7 x. Minus 1 plus 1 is 0. Don't forget your equal sign. 8 plus 1 is 9. Now, I'm dividing both sides by 3/7 since it is 3/7 times x. That will cancel, and I'm left with x. I'm going to go to the side, and I'm going to say 9 divided by 3/7, or 9 times 7/3. Put that 9 over 1, cancel, and I'm left with x equals 21. All right, the last part of your review. These look a little weird, and they tend to also be something that sometimes confuses people, but they will show up. So here's what's going on here. I've got this p minus 1. It's in the top of this division problem or fraction, and it's all over 3. So I have to get rid of the 3 here first. This is divided by 3, so the first thing I'm going to do is I'm going to multiply both sides by 3. These 3's are going to cancel, and I'm left with p minus 1. Negative 4 times 3 is negative 12. Now it's just a one-step equation. It's p minus 1. So I'm going to add 1 to both sides, and I get p equals negative 11. Done, right? Remember, you can always plug that back in and check your work. If I were to put negative 11 here, negative 11 minus 1 is negative 12. Negative 12 divided by 3 is negative 4. I'm going to do it one more time. I have a plus 7 all over, all divided by negative 2. So I have to get rid of that negative 2 first. The inverse of division is multiplication. I'm going to multiply both sides by negative 2. Those will cancel. I'm left with a plus 7 equals negative 12 times negative 2 is positive 24. So I'm going to subtract 7 from both sides, and I get a equals 17. Okay, we're ready for some practice.